So, good day students. You have now arrived at the end of the fourth lesson in this course, and this lesson has tried to introduce you to the whole system. The main idea has been to introduce what is commonly called a helicopter perspective. You will understand that there are much more details that you will have to take into account when you actually work with real cases. But you will also understand that within a course like this there are limits to what can be brought up for discussion, and you will understand that the presentations of individual unit operations have to be superficial to their nature, and so does the description of the methods of analysis. So your current task will be to set up a fictitious case for your own region. You will select a crop or a type of biomass, and you will select a customer. And then you will use the simple methods introduced in this lesson to do a rough estimate of the costs through the supply chain. In case you want, you can also try to estimate the expenses, but the important thing is the cost. Let us first look at what you have done in this lesson so far. The first thing you did was to estimate and quantify regional resources by aid of local statistics. And then you did a simple plan including what might be a trade deal with a neighboring region. Then you estimated the cost for the operations necessary to bring a selected assortment to a roadside location. And then you took an overall view on the supply chain, including transports and comminution, so as to estimate the total efficiency in terms of cost. Following that, you made yourself a simple computer tool to estimate the costs associated with individual steps and operations throughout the supply chain, with special emphasis on storage. And then you thought about what might happen if individual steps in the chain switch place. Roughly speaking, one can say that there are two major types of customers. One is the process industry sector, and in the fifth nugget you thought about process industry end-user demands and how these demands would inflict the quality and how that reflects back onto the supply and resources. Another type of customers are the utility companies. Producing heating, cooling and electricity typically uses steam cycles. So for these customers are the demands on the fuel quality typically comparatively low. So you thought about these customers and how their demands on fuel quality may influence the choice of supply and the resources. Finally, did you set up simple mass balance to sustain the soil, mineral and nutrient balances? And then you discussed ash recycling and ash properties. So, what you have done in this lesson is to take an overall view on the system logistics and economy. Remember, economy only in terms of costs, not in terms of expenses. And then you have taken the end-user demands into consideration. And then you have taken the ecological sustainability into a brief account. So what you shall do now is to set up a reasonably complete but fictitious case for your own region. First, to select a type of biomass that is abundant in your own region. Make an estimate of how much of that biomass is available on an annual basis. I would suggest you select an amount that is available at 75% probability. So you include the risk not to have enough biomass 1 out of 4 years. Then identify one or more customers that may use this biomass. This includes two things. You have to consider the quality of the biomass so that it fits the processes. And then you have to consider the quantity. When thinking about the quantity, you will have to assume something about the total supply chain cost. I would suggest you assume the total cost throughout the supply chain at 20%. So that means you will have to harvest 25% more energy than your end users actually demands. Depending on the type of biomass, perennial, annual, societal or whatever, there may or may not be a need of storing. If there is a need of storage, then will the type of biomass have a strong influence on the demands on the storage location. If the biomass is apt to generate sanitary problems, you will want to have the storage facility far outside any dwelling areas. But if the material is not a sanitary problem, you may have the storage close to a city. If your customer is a utility company, you will want to have the storage reasonably close to the city. If your customer is a process industry, maybe you can have the storage at the industrial estate. Depending on the material heat density, it may be advantageous to place the storage close to the source or close to the end user. Knowing the location of the source, the storage and the end user, you can find the necessary hauling distances. And then it is time to start estimating the total costs. First, the costs for harvesting and bringing the material to a roadside location. And then for the road transports. There will be 2 road transports, source to storage and storage to customer. The storage itself will also introduce a cost into the system. And then you will have to check the nitrogen and phosphorus balances. Once you've done all this, then you know the total cost for the supply. And then you can try to modify the system to see if you can reduce the cost. And if you feel like it, you can also try to find the total and local expenses. But while the costs will be something that is independent of time and place, then will the expenses be something that changes from one location to the other and from time to time. Finally, as usual, write yourself a proper report so that you get used to compiling this type of information in a professional way. You shall not send the report to me. It's only up to you to make a proper report.